Hello everyone, I hope you can hear me. Thanks for joining the webinar today, and we'll be together for a couple hours here. As Marcy said, we'll be taking a few breaks to answer a few questions together. There will be a question and answer session in the middle and one at the end. We have a good team of people at AWC that are monitoring the questions that you will type in the box if you have any. Also at the end of the session I'll give you my email. You'll also have the email address of our info line at AWC if you have further questions. So please have your code book handy if you have one. You might find that handy. And also have this document handy if you've been able to download it. And if you haven't been able to download it, don't get too worried about that. You'll still be able to follow the presentation. What this document is, you're seeing the cover here, and this is something that we developed with the International Code Council. It's intended to very briefly but succinctly cover all the broad topics related to wood construction and wood design in the building code, in the International Building Code. So therefore it covers provisions like allowable building size, special podium occupancies and so forth, sprinkler provisions, fire resistance, permitted wood and non-combustible construction, wood finishes, trim, appendages, and also there's a section on the end about precautions during construction. At times I'll be referring to this document by page number. And again, if you don't have this in front of you, or if you have it on a PDF and you don't want to switch back and forth, that's not a big deal. But it will be a valuable resource to you, we trust, if you do download it after the presentation if you haven't already. This document addresses these use groups in the International Building Code. You're familiar with these use groups, I'm sure, A, B, E, F, I, M, R, S. Wood construction, of course, is possible in other use groups, but the scope of this document is these use groups. Actually, we will have a publication focusing specifically on each of these use groups individually, and there is one posted currently for the 2009 edition of the International Building Code. The main document, Code Conforming Wood Design, that you've downloaded, that addresses all of these. It's a general document, and what we do in the individual publications is split out and use examples specific to the use group that the pamphlet, the individual pamphlet, will address. This will soon be available for the 2012 International Building Code, but in the meantime you have the main document, Code Conforming Wood Design. One of the best uses of the Code Conforming Wood Design document for designers and code officials will be to confirm the correct use of height and area limits in the building code, taking into account all the available increases for frontage and sprinklers and so forth. And so we're going to start this webinar with a section on building size. But first we want to test the polling feature. We want to ask you a question related to the height and area table in the International Building Code. So I'm going to ask Michelle Cambiron if she could come on for a second and put up the poll question, and in this way we'll test the polling feature
Unmuted.
For other points in the seminar.
Yes, thanks, Paul. And this is our, as Paul mentioned, this is our first polling question. And the question is, when choosing wood for business, mercantile, assembly, or other commercial projects, the IBC height and area table, and then you complete the sentence with A, rarely prohibits the choice of wood, B, sometimes prohibits the choice of wood, C, prohibits the choice of wood about half the time, D, usually prohibits the choice of wood, and then the last one, E, almost always prohibits the choice of wood. please vote, and we'll give some time for the audience to answer the question.
Michelle, I'm assuming the audience is seeing the question right now?
Yes.
Okay.
People are answering the question. If you could click on the screen, you can actually click on the screen and put in your answer. Some are typing in the question box, but click on the screen, I believe, and you can respond on your computer. Okay, it says 75% of the audience has voted, 76, 80%. Okay, I think we're going to close the poll right now. So just 5 more seconds, and we'll close the poll. And now we'll share the results. And the results are 28% picked A, rarely prohibits the choice of wood. 52% of the audience said sometimes prohibits the choice of wood. 9% of the audience said C, prohibits the choice of wood about half the time. 8% said D, usually prohibits the choice of wood. And 3% of the audience said almost always prohibits the choice of wood.
Okay, great. It appears like it worked. Polling feature worked. And I appreciate your responses. And that's about what I expected. I think most of you are correct. There's various ways to respond to this, of course, based on your experience or your particular project. What I was interested in particular, was how the height and area table is perceived in regard to wood frame construction, so this information will be helpful to me and to us. I want to mention something before we start into the fundamentals of the IBC about building size, and that is that the topic of the height and area table themselves as to their usefulness and appropriateness actually is a topic, and has been a topic for some time. When they developed the NFPA 5000 Building Safety and Construction Code, one of the topics of a committee there was, what is the real role of the height and area table? Has it perhaps outlived its usefulness, and so forth? And the outcome of that discussion at the time can actually be seen in an alternative approach to the height and area table in Annex D to NFPA 5000. So I just mentioned that. That has to do with using compartmentalization of the building as opposed to limiting a building according to its construction type, limiting the overall size of the building. So I'll just throw that out as you reflect on this poll, and before we go on here, to mention that this is not the only approach, but of course the result of that discussion and the ongoing results of the discussions currently are, in fact, this is what we have now. This has served us well. This is what the IBC still has, and this is what the IBC will have in the 2015 code, although in a little bit different form. So that's where we will begin with the IBC, of course, on the topic of the height and area table itself. And what you have here is a small excerpt of Table 503 right out of the International Building Code. I've only included here the construction types that are applicable to wood frame construction. So this is a truncated table, and I picked some representative use groups over here on the left. And when we look at the International Building Code and we look at this table, we all start here, of course, and we see right away, oh, let's say group M, mercantile. Well, for type 5B, which is unprotected wood frame, I can have 9,000 square feet in one story in regard to a mercantile building. Now, wouldn't it be great if we could really know in a quicker way how big or what allowable size the building can really be. And this is a legitimate question because these numbers go away very quickly in the practical use of the height and area limits of the International Building Code. Take a look at this table. Wouldn't it be great if when we opened the building code, for instance, we saw a table like this for Group M? As you look at this table, and this is in the back of your Code Conforming Wood Design document, in the middle of a whole series of tables that give the maximum allowable area per story for a building of a particular use group. And here we see the Group M immediately if we have sprinklers. This table is for sprinklered buildings, and a Group M is required to be sprinklered, by the way, at 12,000 square feet typically. But right away we see a Type 5B unprotected Group M can actually be 2 stories, and we can have 33,750 square feet per story. We also see a couple other things here. You see that if we're fortunate enough to have 60 feet for a 2-story building, 60 feet around our building, an open perimeter, and the building sprinklered, we're actually unlimited in area. So we get all this information at a quick glance. If we even can go to the second part of the table. I've just switched the slide to the end of the table, going up even to 5 stories, showing you the allowable area per story. We'll talk more about these tables a little bit later in the webinar, but this is what we perceive will be one of the primary and best uses of the Code Conforming Wood Design document. That will be that with the allowable increases, you can see at a quick glance the actual allowable area of a building with the increases already calculated in, with the allowable size per story already calculated in. You can see here that for 5 stories in the building, they get bumped down than for a 4-story building and so forth. We have some very helpful footnotes in each table. And this is actually going to be one of the best uses of this document, is to have as a quick reference at the very beginning of a project for the designers, for code officials, very quick reference, a help to your own calculations as we determine the allowable building size for any particular occupancy. Now, if you didn't have a sprinklered building, in the case of this Group M, you just back up one table, and you have the same table for a non-sprinklered building. All these are in the back of the Code Conforming Wood Design document, and we'll talk about them a little more as we go along. But keep in mind, this is definitely accurate. All these tables are accurate. They've been reviewed by the ICC staff as well as our staff. But they're not the code, are they? They're incremental. They only take an incremental approach to estimating open frontage around the building and that increase. So we do have to rely on the code to get the exact number when it comes down to it. And if we go to the code, we start with this equation 5.1 in the code book. And by the way, as I go along here with this example, you'll find the very same example with perhaps slightly different numbers, but the same procedure, beginning on page 9, the Code Conforming Wood Design document. And we see right away that we have a very basic equation to start with here. And there are 2 factors primarily that we have to determine right off the bat to determine any increases. And the first is the increase factor due to open frontage. This is the open space around the building. That I sub f has a sub-equation. It's here. And if we read the notes below, you see that the F stands for the portion of the building perimeter that has open space around it of at least 20 feet. The P is the total perimeter of the building. And the W will be the width of that open space. We'll talk a little bit more about that. We have another factor, The I sub S factor, that's for sprinklers. Very simply, that factor is always going to be 2 if you have a multi-story building, 3 if you have a single-story building. Now we get to the W term. There's also a separate equation for this. That is, if you want to use a weighted average, which the code allows you to use in the case of W, it involves adding the products of the length of the perimeter that has a particular width of open space, adding all those products together, dividing by the total perimeter that has open frontage, and you come up with a weighted average W. I'll go through an example a little bit later. First of all, let's do a very simple example together. If we did have a single-story type 5B, wood frame unprotected, grade school, what's the use group? E, thank you, I heard many of you. No, I didn't really, but I know you said it. Let's say this is provided with an NFPA 13 compliant sprinkler system, and it's located on the lot as shown here. So we have 2 sides that are open. Let's go back to our main equation. I've kept a little site plan down in the lower right. First of all, the tabular area, we can fill that in right away. That's going to be 9,500 square feet. And where's that from? It's right out of table 503. Now we're going to look for the I sub F term. You saw this equation before. And we see that the distance of, or the perimeter that has open frontage is these 2 sides. And we got 60 feet and 40 feet. The code tells us when it's greater than 30 feet, we have to use 30. It's section 506.2.1. We have an I sub S term. What is this for this building? Remember, we have a single-story school building. What's the sprinkler factor? 3, correct. Plug all these numbers in. We come up with an allowable area per story of 40,375 square feet. And we check that against the actual area. It's fine. Did well. Now, we didn't have to use a weighted average W in this example, but what if we had different circumstances and we did want to use a weighted average W as shown here? Let's take a look at this drawing for a minute. And this, by the way, is in your Code Conforming Wood Design document on page 10. We're going to go ahead and say that here's wall 1, wall 2, wall 3, wall 4, of course. We've got a distance, a width here of a certain amount, and here of a certain amount. We'll move this picture down to the corner. We'll put some values to these. Here's a basic equation for weighted average. And let's say that W1 here is 22 feet, W2 is 35, 33 down here, and 30 over here. How do we calculate this? Well, here's the calculation. If our building is square with 200 feet on a side, that was given to us up here, then the equation looks like this: 200 times 22. That's the width of open space on this side. 200 times 30, 30, 30. You say, what? Where did the 30 come from? Remember, you got open width of more than 35 feet, or I'm sorry, of more than 30 feet. You got to use 30. That's where that plugs in there. What do we come up with? I'm sorry, I didn't mean to move on. 28 feet. Yeah, that's our weighted average W to plug back into our I sub F equation. A couple cautionary notes here. There, as you know, if you're used to using the code at all, most of you are, there's such a thing as fire separation distance. That's the FSD here. Fire separation distance is defined as what is used to measure to a lot line for the purposes of determining the rating of this exterior wall. It may require a rating, fire resistance rating. Openings may need to be protected as well. We have to measure if you have two buildings on the same lot, you have to measure the fire separation distance to an imaginary lot line between the two buildings. That way there's appropriate protection on this exterior wall, appropriate protection for this exterior wall. The W, however, in our I sub F subcalculation for width of open space can go all the way to the adjacent building on the same lot. The code allows that specifically. How about this case? In this case, it's a real lot line here. If there's a real lot line there, then the W has to go to the real lot line. In other words, this building is owned by someone else. It's the same as fire separation distance. However, if you're next to a public way, you can take that W all the way across in your calculations for building size. The fire separation distance, however, goes to the center line of the public way. So be aware of those distinctions as you use and as you calculate your W. All right. Get out your scratch paper. We're not going to really test you on this. I'm going to actually work it with you. But I am going to pause a few times as we go through an example here. I want you to be comfortable. Those of you who care to do this example with me, I hope you all do, to be comfortable actually working through these equations quickly. It's a review for many of you, and possibly a useful review for some of you. Maybe you've done this for the first time. Here's our example. 3-story retail store, 3A construction, street width of 22 feet. In this case, no sprinklers, and we need to determine the area limitation per story. Go to our basic equation. Here's the first problem, or the first thing we need to determine. What is the tabular area for this retail store? What do we plug in for the A sub T? If you have your code book, look that up. Here's the answer, 18,500, because what? It's a group M, mercantile. It's type 3A. We're in table 503. All right, so we'll plug that in right away. We have A sub T is 18,500 in each of those places. Now how about the I sub F term? Can you do this? We're not going to do a weighted average W. I'm giving that to you here. W equals 28 feet. So to calculate the I sub F, you need to take a look at the plan, see how much frontage there is in the perimeter, and then plug in your F, and then put that over the total perimeter. Plug in your 28 here. Those of you who have calculators, or if you're good, you can do it by hand. 0.054 is the answer you should have gotten. That's your I sub F term. Very good. You say, well, what about that side? Why didn't we use that in the W calculation? If you didn't get 0.54, might be because you tried to use your 15 feet on the one side in your calculation. We don't use that because it has to be at least 20 feet to be considered open frontage. All right, what's your I sub S in this case? You remember? Given in this example was, do we have sprinklers? No, no sprinklers. So I sub S equals 0. Right, no sprinklers. There's no increase for sprinklers in this case. Now we have everything we need to calculate our allowable area per story. And we plug in the numbers. And if you did it quickly, you should have gotten 28,490 square feet per floor. Our actual area in this case is 27,600, so we're okay. All right, very good. We know that allowable area is only one criteria. We also have Table 503, regulating the height of a building. And here we go, the table 503, and again this is a truncated table, but it limits the height of, for instance, a 5A building to 50 feet. There's also a story limit in this table. In the case of a B, for instance, a story is limited. Type 5A is stories is 3 stories. All right. I think we're familiar with that. Here's how it works if you have sprinklers, automatic fire suppression system in the building. You have a 3-story building, for instance, and you add sprinklers, then you typically get to add 1 story to the building height limit in 20 feet. And that's for a full NFPA 13 system. Let's take a look at the code section for a moment. It actually gives that increase. It's cumulative. Highlighted the sentence here. This is you can take this increase for height along with the full increases for area under the model code. What's going on here in this section for Group R buildings? Take a look. Group R buildings reference. This acts like an exception. For Group R buildings equipped throughout with an approved automatic sprinkler system in accordance with this section, 903.312. That section, if you go back and read it, that refers to the standard NFPA 13R. It's a residential sprinkler standard, a little bit different from the full NFPA 13 system. It does allow the omission of sprinklers in certain areas of the building. In that case, then you're limited to 4 stories total. That's the top limit for Group R, using this sprinkler system. Now, if you have a full 13 system up here, then this does not apply down here. Your Group Rs, of course, can go higher if you have a full 13 system. All right. Want you to be aware that we can go ahead and calculate an allowable area for a building under Chapter 5, but we do always have to check Chapter 9. Chapter 9 has a direct effect on the allowable area of the building. Why is that? Well, you calculate your allowable area in Chapter 5, and you go to Chapter 9 and you might find out you can't have that non-sprinkler building for the use group that you have and the type of construction. Non-sprinklered is not permitted. You might find that in any number of given cases. For instance, if you had a Group M, mercantile, or an S, they are going to require sprinklers at 12,000 square feet fire area. Or if you have a combined fire area of 24,000 square feet, that also would require sprinklers in an M or an S. If you have a Group A2, a restaurant, you've got sprinkler if you have a fire area exceeding 5,000 square feet, or if the restaurant's located above the level of exit discharge, you have to have sprinklers right away, or if you have more than 100 occupants. So you always have to go back here to Chapter 9 and check this. I want to demonstrate how this can catch you possibly. This is the same exercise that we looked at previously that you figured out the allowable area for that building. Now, can we really have no sprinklers in this building? Some of you code officials probably caught this already. What do you mean no sprinklers? This building is going to be required to have sprinklers. As a matter of fact, it is required to have sprinklers. If we go back to Chapter 9, and we find out here that if a Group M fire area exceeds 12,000 square feet, you got to have sprinklers. Well, you say, well, maybe there's fire barriers in there to separate out the fire area into smaller chunks. That may be true. And you could do that and not have sprinklers, but most likely this Group M, this 3-story Group M, certainly if it was a 4-story Group M, you'd have to have sprinklers right off the bat, right here, no matter how big it is. Because number 2 here says if it's located more than 3 stories above grade plane, your group M has to have sprinklers. So don't be caught by neglecting to look at the Chapter 9 limits, the sprinkler thresholds there. The code has many trade-offs for sprinklers, including reductions in corridor ratings, corridor opening protection reductions. You get a lot of flexibility in means of egress. There are reductions in dwelling unit separations and so forth. The list is here. This is only mentioning a few. There is a lot of active fire suppression, of course. Very effective, and it's superior in many ways to passive protection. Passive protection is also needed in many cases, but it always makes sense in a project to see what the total cost would be with sprinklers and without sprinklers, taking into account all the trade-offs that you get in the code. Many times it really makes it worth it. Certainly from a life safety standpoint, it's always worth it to have sprinklers in the building. Well, we've looked at allowable area per floor. How about the complete size of the building? The code limits that too, doesn't it? This discussion is starting on page 14 of Code Conforming Wood Design, and there's an example there. We're going to go through this example, but the primary principle here is that if you have a building 3 or more stories above grade, you've maxed and you have the total maximum allowable area per story, you're maxed out for the size of that building. How does that work? Well, you have 1 story at 37,500 square feet. I pulled a number out of the air. Let's say we calculated our allowable area per story at 37,500. If we have a 2-story building, Section 50, in Chapter 5, it says you can have twice that allowable area. So now we have a building twice times 37,500, and we can even go a 3rd story. Now we've reached the maximum allowable area of our building. If we take another story at the top, the total allowable area remains 3 times the allowable area per story. So we have to reduce the area of that. In this case, if our building has a maximum allowable area of 112,500 square feet, then for 4 stories of equal area, that would be split between the 4 stories. That's how it looks. Now, you can have 1 story that's as big as the allowable area for a single-story building. So you could put that somewhere. It doesn't have to be the bottom. But then, of course, the upper stories, to even out the areas, are going to be further reduced. In the case of our example, they're going to go down to 25,000 square feet. That's how it works for total building size. Now, you can have a basement. Section 506.4 says you can include a basement. You don't have to include that in the allowable area of the building. So put a basement on that story there in the bottom. What about mixed occupancy buildings? So far, we've only talked about single occupancy buildings. That's the easy part. Mixed occupancy is a little bit more complicated. There are several alternatives. I'm not going to go through them in detail. It would take the rest of the time, or a good portion of the rest of our time. But I will say, here are the alternatives. Non-separated mixed-use buildings, Section 508.3. You can have different use groups in a building. If they're non-separated, then whatever is the most restrictive use group in terms of allowable area, that's going to determine the size of your building. Another alternative is separated mixed-use groups. In this, you put an occupancy separation, fire resistance rated separation between use groups, different use groups. And this also involves using a formula where you add together the ratios of the allowable area, or I'm sorry, the actual area of each use group to the allowable area of the use group. And you add those ratios, and on a single story, they have to be less than 1. the sum of those ratios. In a multi-story building, you find that for each story, you sum the ratios of the actual area to allowable areas for each use group on each story, and that has to be less than 3 for a multi-story building. So there's a way to do it for a single floor. There's a way to do it for the whole building using the separated mixed-use option. I'm going to drop back now. We started the webinar with the reference to the tables in the back of the Code Conforming Wood Design. We went through the basic height and area out of the International Building Code, and I want to run through an example of using these tables a little more specifically so that you get a little comfortable with this. Let's say, just taking schools for an example, we have back on page 32 of your Code Conforming Wood Design document, you'll find this table. It's for Group E, non-sprinklered Group E. By the way, now we have to be careful, don't we? Because for Group E, when you get up to 12,000 square feet, you have to have sprinklers. That's a Chapter 9 threshold. So, but this is what the table looks like. The bottom of the table, if you're back there on page 32, you have footnotes that look like this. I'm only pointing this out to show you that we tried to be as helpful as possible in the footnotes by putting in footnotes like this. Wait a second, it says, you're in the non-sprinklered table, but you got to have sprinklers at 12,000 square feet, and it gives you the code section reference. Again, I think these are going to be very useful if you keep these on your shelf to check and to recheck yourself as you estimate building size for wood frame construction. In this example, if we did have a Group E, 5B, 13 system, similar example to what we had before, we have 50% open frontage based on the site plan. And we go directly to page 32. This is a sprinklered Group E. So on page 32, table 6 is the correct table. Right away, we go to 1 story. We have 50% open frontage. And we see that our type 5B sprinklered Group E occupancy can be 40,370 square feet. Very direct compared to doing all the calculations with the formulas. Here's another table in the back. This one happens to be on page 10, or sorry, page 36, and it's table 10, Group I, for instance, a nursing home. This one makes reference to something other than a full 13 system. The code does permit certain circumstances for a nursing home or Group I1, does permit the use of a 13R or even a 13D system. The bottom of the table, here we've got the footnotes helping us with the proper use, the table showing us some of the assumptions, and also some of the code restraints regarding sprinklers in this case. Here's an example we'll do together. I'll do with you. Let's say we do have a nursing home Group I1. The group's listed at the top of this slide. And we're looking at a 3B building, and it does have a 13R system. Determine the maximum allowable building area using the Code Conforming Wood Design tables in the back of the book. All right. So you had the example. I'm going to put it back up. We do have a polling question to see if you're getting to the right table, if you're using the document, if you'd like to try this. Michelle, I'll invite you to come back and read the question quickly, and we'll do one more polling question.
Great, thanks. Okay, requires audience participation, and the question is, using the tables in the back, what is the maximum area per floor for this example using the tables at the end of the CCWD document? And perhaps, Paul, maybe you can repeat what the example stated.
Yeah, because they can't see it now, can they? I'm sorry about that.
Right, yeah.
All right, we have a group I1, and you should be flipping through the back of the Code Conforming Wood Design. It has an NFPA 13R sprinkler system, and it has 50% of the perimeter that has open frontage and qualifies for an increase.
Great. And once again, the question is, what is the maximum area per floor for this example using the tables at the end of the CCWD document? A, 16,250 square feet, B, 12,500 square feet, C, 32,500 square feet, or D, 2 stories are not permitted. And the audience is voting, and we have 19% of the audience participation and quickly increasing. Okay, it's coming in. And we're dealing with a group I1 occupancy. And the type of construction is type 3B, 2 stories, right? I know.
2 stories, that's right. 2 stories and 50% open space.
And a sprinklered building, 13R.
NFPA 13R.
Okay, we have 2 stories, someone's asked. Okay, and if you don't have the book, Brian's been sending you links on where you can download the book, but I'm going to close the poll, and then we'll share the answer. Okay, the question again is, what is the maximum area per floor for this example using tables at the end of the CCWD? And Paul, do you want to repeat the building we're talking about?
It's a group I1, nursing home, 13R system, 2 stories. And the table that you should have found or should have gone to is table 10, page 36. I can't read the results there. Michelle, you have to read those to me.
Right. The 19% responded to saying A was the answer, 16,250 square feet. 49% of the audience said 12,500 square feet. 28%, I should say, of the responders that responded to the survey said 32,500 square feet, and 4% said 2 stories are not permitted.
Okay. Well done. The majority of the responders got it correct. If you want to go to my slide now, Michelle, I can show them the table.
Okay.
I think you can see that now. This is the table that you should have gone to and found the answer. And 12,500 is correct, so well done. And perhaps there's a variable or two for some of you that threw you off. Perhaps you were just guessing. But anyway, as you sift through these tables, my purpose was to get you looking at the tables, and I hope they're useful. We're going to move on now from the allowable area of the building in the basic sense and talk about some special occupancies that are permitted in Chapter 5 that depart from the normal building size limits. This is on page 16 and 17 of Code Conforming Wood Design. Stack buildings, or podium buildings, as they're sometimes referred to, also pedestal buildings. There are several options there. What happens with these is you're allowed to have 2 different construction types in one building. There's a whole list of options, 6 or 7 at least. The one that's most commonly used is 510.2. 510.2 seems to have the most flexibility, and over the years this section's gotten the most attention at code development hearings. First of all, the uses above and below a horizontal separation are permitted to be a number of different use groups. Here's what it may look like. The horizontal separation of 3 hours is required here in section 510.2. And the flexibility with 510.2 comes in with the number of use groups you can have up here or down here. It's a broad number of use groups. It's no longer just parking down here. The distinction here, which makes it a little bit different in terms of height limits, is you get to measure the height in stories above the horizontal separation. So you start measuring the height in stories from the top of the building below. However, you're still limited in the number of feet from grade as measured from grade for this upper building. Now, be a little, I'll note it's also going to be true that in the 2015 code, when it comes out, there was a code change approved that said that this first building down here no longer has to be only 1 story. This is type 1 construction. That's one of the conditions. It's typically parking, but not always. But this can be more than 1 story under the 2015 code. So in a case where you may want to top off a building with 1 or 2 stories of wood frame above 2 or 3 stories of type 1 parking or whatever you have down there, that's possible as well. That's only one of the alternatives in the special occupancy section 510. This used to be 509 in the 2009 IBC. It's now section 510. There's other alternatives there. There's various alternatives for using 2 different construction types in 1 building. Most of them are derived from trying to allow parking beneath an apartment building, for instance. But now there can be any number of different occupancies in these buildings. There is a category, of course, for unlimited area buildings. And we've already seen this briefly in one of the first tables out of Code Conforming Wood Design. But business, factory, mercantile, storage, 60 feet around the building, NFPA 13 system, unlimited in area, 1 or 2 story. As you can see, this is quite liberal. It's more often than not in the case of buildings on a site with open frontage, if there are sprinklers. In these use groups, you're limited more traditionally by what you can do with wood construction. That is changing. What you can do with wood construction, of course, is changing due to the introduction of new and innovative mass timber products, such as CLT, so forth. We might touch on that a little bit later. But unlimited area buildings are permitted for these use groups. Also permitted to even have within an unlimited area building rather large assembly occupancy, even a theater. For instance, if you had an unlimited area group M mercantile, a theater at one end or in there somewhere, still would not prohibit it from being an unlimited area building. There are certain conditions. One of them is, in the case of wood frame construction, it has to be at least type 3 or 4. The occupancies has to be separated with fire resistance rated construction. There are some exiting provisions as well. There is a category for a more typical assembly building, A3, church and so forth, to be unlimited in area, type 3 or 4 construction. You find all those limits in 507.7. This has to do with this, by the way, unlimited area buildings is in section 507 of your code. If you go down here for unlimited area group A4, this is indoor sporting events. There's a category for unlimited area there. Type 3A, 3B, and 4 construction. Even for schools, you can have an unlimited area school building, even wood frame, type 3A or 4. The conditions are found in 507.10. Each classroom has to have 2 means of egress, one directly to the exterior. You've got 60 feet all the way around the building, and so forth. if you're making something, non-combustible, manufacturing, storage can be unlimited in area even without sprinklers, any construction type. And then finally, let's say you have a site that you don't have 60 feet all the way around. In every other way, you comply with the requirements to be an unlimited area building, but you don't have that 60 feet on one or two sides, as shown in this picture here. Well, the code does have an exception allowing you to go ahead and rate those exterior walls and the openings for 3 hours, still be unlimited in area. Believe it or not, we're coming up on the hour mark for this webinar. We've dealt with the size of buildings and various special occupancies. We've dealt with a number of features of the Code Conforming Wood Design which summarize and sort of make accessible the building side provisions of the International Building Code. Gone through a lot. Maybe you have questions. Maybe questions have been coming in. And this might be a good time. We're about halfway through. Michelle, if we could take a few questions and just break things up a little bit, maybe give some people a chance to get something to drink or something and come back to the computer.
Great. We have been having quite a few questions come in, which is great. Glad to see that the audience is interacting with the webinar. The first question we have is, why is there no open perimeter? Oh, it just moved. Why is there, sorry, my question bar just moved. Oh, okay. Why is there no open perimeter increase for widths greater than 30 feet?
That's a great question. Actually, if you have a width of 60 feet, as we've seen, you get lots more benefits. That's where you kick into the unlimited area building provisions. The question might be, if you're between 30 and 60 feet, then maybe you should get some additional credit for that. Mm-hmm. And I think the code does actually give you some credit for that. I'm going to flip through right now and look real quick. Okay. Yeah, if you, for whoever asked the question, if you take a look in the code at 506.2.1, there is an exception that allows that value of W to be increased if you're between 30 and 60 feet, and you would otherwise comply with the requirements for an unlimited area building. So there's some attempt in the code to give you more. As for the reason why, I'm just not sure. They had to make the cutoff somewhere. I guess they figured 30 feet is a reasonable distance that you've reduced the exposure to other buildings down to as low as it can go, or 60 feet is even better, of course. So then you're just reverting then to the regular limits based on the risks associated with the building itself, and they just had to stop at that point.
But related to the area increase calculation, that W is only maximum of 30 feet, correct? Or is that correct?
Correct. Unless you comply with all the provisions for an unlimited area building and all those conditions, sprinklers and so forth.
Right.
If you don't comply with all those conditions, it stops at 30 feet. That's correct. You can only plug in 30 for your W in your weighted average calculation. Correct.
Yeah, that's a really good question. Okay, and a really good answer. Okay, the next question is, what counts as open space? I think they mean what defines open space. Must it be accessible by a fire truck?
Yeah, that's a great question. And I believe ICC, in some of their publications, has issued some interpretations on this question. I'm going to take a stab at what I recall from how an ICC staff person might answer this. It does depend on the local jurisdiction to some extent. But the idea here is you want to be able to get a fire truck up to the building. So therefore, open space could not be a body of water, like a lake behind the building. That would not be considered open space. However, a parking lot is considered open space. Most jurisdictions would say if you had a stand of trees that were very dense, if there was no firefighter access on that side of the building, those are the kind of things you have to be careful of. It may not be considered open space. Certainly, of course, you measure your open space to the property line always, but you're right. The main idea here is what may restrict your consideration of being open space would be whether you have good firefighter access or not. That's what I recall from some of the interpretations that I've read.
And it's not construction type dependent, it's any building, right? The open space.
Correct. Applies to all construction types, what I just said.
Okay. Okay, and the next question is, would you explain the difference between type A and B construction, for example, or type 5A and type 5B?
That's a great question too. Back at table 503, we had the A and the B at the top under various construction types. The A typically designates 1 hour rated construction for your structural elements in the building. So if you have a 5A building, it means it's wood frame typically, but the walls, floors, and roof are rated for 1 hour fire resistance, and no, your openings would not be required to be protected in those rated walls, floors, and ceilings unless the code required them to be rated for purposes of some type of separation. If it's just required to be rated by the construction type, the A, so to speak, then you have the rating required, but the openings are unlimited and not required to be protected. So that applies to type B as well. You have type 3B is type 3 building with no particular fire ratings. Type 3A is a type 3 building that's 1 hour rated throughout.
And I think later on in your presentation you're going to get into table 601 where it talks about the fire resistance ratings of the elements.
I will show that table.
Yeah.
Right.
Okay, and then another question is, do you have to have a certain percentage of frontage on a street?
If you have a street next to a building that is a public way, you always get to use that as frontage. There's no requirement, and you would go again to all the way across the street for your W measurement to the center line for your fire separation distance measurement, but there's no requirement that that street has to be any particular width. There's no requirement. There may be setback requirements for the street itself. That's not really regulated by the building code. But in terms of the building and the exterior wall rating, you can always use that street no matter how narrow it is for open frontage if you have the width.
Okay, great. Okay, I think we have time for a few more. What are the changes between 2009 and 2012 CCWD?
Wow, that's a good question. Well, the short answer would be same as the changes between the 2009 IBC and the 2012 IBC. Other than that, it looks the same. There's a few adjustments. So it's a pretty broad discussion to talk about the changes between the 2009 and 2012 IBC. But what you see in the 2012 will be treated the same in the 2009 with the adjustments that it's consistent with the 2009 code. ICC has an excellent publication, by the way, called Significant Changes Between the Codes. If you didn't know about those, between 2009 and 2012 IBC, that's a great resource.
Okay, great. And let's take one more question, and then I have a comment to make about the CCWD. This question is, or actually, why don't I just say it now since we were on the CCWD. There's been questions coming in regarding the CCWD document not matching the presentation, and that is correct. This presentation will give you information that is actually in the CCWD, and I think you mentioned something about this in the beginning of the presentation. Is that right, Paul?
Some of the examples, the numbers are adjusted a little bit. Both are correct, however, if the numbers are, to best to my knowledge. Now, if you've caught a mistake, email me or email us and we'll correct it. But yeah, some of the things have been adjusted. The slides are have a little bit better illustration for the webinar format, so they don't match up exactly. But it should be the same content.
Right. Okay, here's one last question. What about situations where the building walls are not parallel to other buildings for measuring the open width?
Okay, you always measure the fire separation distance at right angles from the exterior wall. And if you want to know why I say that, you actually go to the definition of fire separation distance in the building code, and you'll see that it says the distance measured from the building face to one of the following: lot line, center line of a public way, or the imaginary lot line. So very simply, you always measure at right angles from the building wall, the exterior building wall.
I think the question is referring to, say, if you don't have a perfect rectangle, which, you know, all our buildings are perfectly rectangular, but just that one case where the walls pop in and out, you know, you don't have they were talking about what do you use for your width? The furthest wall along that line, do you understand what I'm saying?
Yeah, that's a good candidate then for the weighted average. You know, if you have, if you're measuring at right angles from your exterior wall, well, I can see how it might be tough to do a weighted average because it's changing infinitely along that line, isn't it?
Yeah.
So, yeah, I guess what you'd have to do is you could take an average there. The width would be an average between your narrowest and your widest portion.
Okay.
And check with your code official, see how he wants you to do it.
Okay, great. Great questions. Okay, so we'll turn it back over to Paul, and he'll continue with your presentation.
Okay, thanks, Michelle. What about fire resistance in the building code? Page 17 and 18 of Code Conforming Wood Design. Here, first of all, we have Table 601. This again is this is a less truncated table. It might be a little truncated from the code. All the footnotes are not shown here. You're familiar with this table. I want to point out as we talk about fire resistance that these are the ratings that you see in this table for ratings due to construction type. You have the building elements over here, types of construction across the top, the ratings required in the individual box. These are for ratings according to construction type. However, you should be conscious, and most of you are, you could have many elements required to be rated in any building, even if this says 0 in this box for construction type. You have exit enclosures, you have fire barriers limiting fire areas, you have horizontal exits, control areas for hazardous materials, dwelling unit separations, smoke barriers, and so forth. All those require ratings for a different reason. This is ratings only for construction type. And those ratings are found in other tables, like 508.4 for occupancy separation, Table 602 for exterior wall rating based on fire separation distance, and so forth. So this is not the only location that you go to get ratings. When a rating is required, however, the code actually permits 5 methods to determine and to establish fire resistance. The tested fire assembly per ASTM E119 in section 702.3 of the code, or UL 263, that's the most common. Perhaps you have a UL fire resistance directory, a gypsum association directory, or so forth, and you find your tested assembly, and that's what you use. However, there's these other alternatives as well. When you do use by the way, I went on to the UL website. I happened to receive a disc, a UL fire resistance disc some time ago, and that's what you're seeing a screenshot of there. But they have them easily accessible now on their website for free, fire resistance designs and so forth. The one on the right is the Gypsum Association. So that's very common. But you can also choose a prescriptive assembly right out of the code book itself in section 721. And those assemblies have been tested, and they're prescriptive assemblies, generic if you would, that you could use right out of the code book. And also in that section 703.3 on alternative fire resistance, establishing fire resistance ratings, you also have one of those options that says fire resistance designs documented in approved sources. By the way, I'll add a little caveat here. If you look at the 2012 code, 703.3, it doesn't say approved sources, it just says in sources. That's a typo. It does have to be approved, an approved source, and all the code officials listening will tell you that means the code official has to be okay with the source that you use for fire resistance designs. Another alternative is calculated fire resistance. Now there's two ways to think about this, and there's two topics associated with calculation. The first one would be calculating the fire resistance of exposed timber construction, beams and columns that have no other protection, they're exposed. The code actually tells you to go to Chapter 16 of the National Design Specification. That's our standard for wood design, the NDS. There is another method in the code for calculating fire resistance of exposed members. That is back in section 722 in the 2012 code. And that method back there, 722.6.3, will work, but we highly recommend that you follow the main section 722.1 of the code and go to the NDS. Why is that? Well, the NDS method is more flexible. It allows up to 2-hour ratings. And also, it is a little better in terms of avoiding mistakes. The 722.6.3 method in the back of Chapter 7 will work, as I said, but that's going away actually in the 2015 code. So you may want to become familiar with the calculation method in the NDS. I said there's two, oh, by the way, here's technical report number 10, downloadable from our website, that gives you the background on that method and also explanations and examples. Now, I mentioned that there's two topics related to calculated fire resistance. The other is calculating the fire resistance of wood frame assemblies, not individual timber members. This is referred to as the component additive method. And this method first came about when the Fire Test Board of the National Research Council of Canada in the 1960s compared hundreds of tested assemblies, walls and horizontal assemblies, and drew conclusions about them. The goal was to determine fire resistance rating of an untested assembly that had the same essential characteristics as a tested one. And thereby we could come up with a way to actually put together an assembly without having to test each one individually. For instance, code officials are now pretty comfortable with the knowledge that a wall that has studs at 16 inches on center with type 5/8 type X gypsum board on each side is a 1-hour wall, a symmetric 1-hour wall. This again is called the component additive method. It's back in section 722.6. You'll see this table is right out of the code book where you can put together an assembly up to 1 hour, rated, using this component additive method. It comes from this document. The code provisions actually came from the same source that this document was derived from. This is downloadable on our website, DCA4. And very important, in this document, you may find interesting, especially code officials, but also designers, the rules associated and that were derived from this method. For instance, you might like to know that the presence of a continuous air gap in a rated assembly can only increase the fire resistance of the assembly. That's one of the conclusions drawn from this study. The fire resistance cannot be decreased by an additional layer of panel material. Those are the kind of things that were derived from the study and the development of the component additive method. And this can become useful, especially to code officials, when they're making judgments on assemblies perhaps in existing buildings, or when an assembly departs a little bit in terms of spacing or air spaces and so forth from what may be listed. You can use this to make good practical judgments. Another alternative for establishing fire resistance is an engineering analysis. That's one of the original alternatives in 703.3. The DCA4 that we just looked at embodies this for 1 hour assemblies. Let me take a look at that again. Actually, it would be the DCA3, which actually lists tested assemblies, would embody this for 1 hour assemblies. But it can be applied to other elements and other ratings with good, appropriate, and qualified fire protection engineering judgment. The point is that if you don't have a tested assembly, you can't have an engineering analysis for establishing fire resistance. All right, Michelle, I'm going to call you back and have a little test on fire resistance here. This is simple, no calculations, no looking up is involved. Just see if you're still with me and still listening. We have a little poll question here.
And before we get into the poll, I wanted to mention that all of these documents that Paul is referencing are referenced in the CCWD document throughout the body of the document. For example, on page 18 of the CCWD, where we're talking about calculated fire resistance, it mentions the documents that he's referencing. So that'll be there for you to answer. The question is, which of the following methods are permitted by the code to establish a fire resistance rating? Select all correct answers. That means that there may be more than one answer. A, using a fire protection engineering analysis. B, choosing a prescriptive assembly from the code. C, using non-combustible materials for a 30-minute baseline. D, calculating fire resistance per Chapter 16 of the NDS. Or E, field tests during construction. And the votes are coming in. We have 57% of the vote in right now. And remember, there may be more than one answer. Select all that apply. Okay, I'm going to go ahead and close the poll. Or you think that's enough time, Paul?
Yep, let's go.
Okay. So we're closing the poll. And I should also note that you're not going to be graded on your answers, and there's no pass or fail, or everybody passes. We're not going to come back and say you guys all failed and you don't get a certificate. Okay. So the answers, which of the following methods are permitted by the code to establish a fire resistance rating? Select all correct answers. 89% of the responders chose A, using a fire protection engineering analysis.
That's correct.
95% chose choosing a prescriptive assembly from the code. Did you want to mention something?
That'll work. Those two are correct. I'm just telling you they're correct as we go here.
Okay. And then 19% chose using non-combustible materials for a 30-minute baseline.
That one's incorrect. It's false.
And then 86% chose calculated fire resistance per chapter 16 of the NDS.
Well done.
And then the last one, 12% of the responding to the poll chose field testing during construction.
No, I know of no way to field test for fire resistance during construction, so that one is incorrect as well.
Okay.
Thank you for your responses. I can see that you've got it pretty right on the fire resistance ratings. Well done.
So I'll hand it back to you.
Okay. What about firewalls? This is on page 15, or 16 rather, of the Code Conforming Wood Design. Of course, as you know already, most of you, firewalls define a building. In other words, you start your allowable building area over with a firewall. It has very specific requirements, 706. Firewall is not a fire barrier. It's not a fire partition. It's not a smoke barrier, not smoke partition. Those all have their own separate requirements and separate sections in the code. Here's the table out of the code book that governs the rating of a firewall. You typically get to go down for 2 hours for these main use groups here. You go down 2 hours according to the footnote in types 2 or 5 construction. And in type 5 construction, you can have firewalls of wood frame construction. Type 3 and 4, however, firewalls have to be non-combustible materials. And some of you may be thinking of the question, well, we know we're able to use fire retardant treated wood in exterior walls in type 3 and 4. How about firewalls? The answer is no. You can't use, there's no provision in the code for using fire retardant treated wood in a firewall in type 3 and 4 construction. And speaking of types of construction, I'm going to lead up now to where wood can be used in non-combustible construction types. So we'll do a quick review of type of construction. This will be very basic. Type 5, of course, any material is permitted. These are again split in accordance with the questionnaire between types 5A and 5B, 5A being 1 hour. Type 4 is heavy timber construction. Exterior walls, by definition now, in type 4 you have to have exterior walls of non-combustible materials or fire retardant treated wood. And the interior building elements of heavy timber or laminated wood, structural composite lumber, whatever, meeting minimum dimensions and without concealed spaces. And if you go to Chapter 6, under Type 4, you'll see the minimum dimensions required for each element, whether it be a column, even roof decking, and so forth, to meet the definition of heavy timber. Type 3 construction. By definition, Type 3 construction has to have non-combustible or fire retardant treated wood exterior walls. Type 3 construction may be an area, in my opinion, where some code development is in order. Type 3 construction comes from originally what was called ordinary construction, which is traditionally masonry exterior walls on the exterior of a building. These were describing, originally in the legacy codes, these were describing buildings in urban areas with rather tight spacing in perhaps a fire district. Exterior walls of masonry to prevent conflagration or to give some protection, at least from a fire safety standpoint. And then the interior would be heavy timber or wood frame construction. Type 3 now, the code has for some time permitted fire retardant treated wood in the exterior walls. So the question comes up from time to time about the details regarding exterior walls in Type 3 construction. this is where the code is beginning to be improved and will continue to be, focusing on the role of that exterior wall, especially on a site where there is no proximity to other buildings. The question comes up, what is the purpose, what is the goal of the rating? And I'm not suggesting that it shouldn't be a code requirement. It may be a very legitimate code requirement for the rating. What I'm suggesting is if the code were developed to think about the goal of that rating and what its purpose is in the exterior at the perimeter of the building, most code officials who encounter a question when it comes to wood frame have come up with some very practical solutions to treating that rating or addressing that rating in the exterior wall in regard to the details of structural connections for wood frame construction. And the code is moving that way in a practical way. There is one change in the 2015 code that has removed some ambiguous language about the wall staying in place for the entire time of the rating and so forth. The point is we want to make sure that the code provisions have a unified and good purpose in terms of the rating of the exterior wall from a practical standpoint. Oftentimes I think sometimes we get concerned about protecting the exterior wall from the interior of the building, which doesn't seem to make a lot of sense to me. However, it's a broad discussion. Many code officials take a very practical approach, and we're thankful for that. It's a little bit underdeveloped in the code, and we're going to be working on that a little bit. Types 1 and 2 construction, of course, are non-combustible, and you can't use wood in the major structural elements of the building. However, there's lots of places that you can use wood in non-combustible construction. You should be aware of this. It's on page 18 and 19 of the Code Conforming Wood Design. All these locations are listed in section 603. There's actually 25 applications where combustible materials permitted, and very prominent in that list in 603 is fire retardant treated wood. It's permitted in these locations that you see on the slide. These permissions are in addition to their appropriate place as part of the exterior wall in type 3 or type 4 construction. In addition, you have a rather large exception for use in roofs and unbearing exterior walls and so forth. This heavy timber, this comes from a footnote in table 601. If you have 1 hour or less fire resistance rated construction in the non-combustible construction types, you can use heavy timber for your roof structure. There's a few other examples right here. Windows and doors, partitions of limited height, there's some conditions on those. Exterior wall coverings, balconies. These are where you can use wood in non-combustible, that is types 1 and types 1 and 2 buildings. Michelle, do we want to do another poll question here, or do we want to roll on? What do you think? I think we'll roll on. By surprise. I'm going to go ahead and go. We have another question at the end. I think I'll save our, oh, maybe I'm just not hearing Michelle.
I lost my audio for a second.
I see that. There you go. Okay, thank you. I see that they have the question in front of them.
Okay, so we'll just go ahead. Which of the following best describes the permitted use of wood in buildings of non-combustible construction types? Wood is not permitted, A. B. Wood is permitted for all non-structural applications. C. Wood is permitted for finished materials and trim only. Or D. Wood is permitted in the applications listed in section 603. It looks like this one we're getting some great responses. So I'll go ahead and a few more. Okay, I'll go ahead and close the poll and show the results. Okay, the results are, well, which is the following best describes the permitted use of wood in buildings of non-combustible construction types? 1% responded to wood is not permitted. 12% said that wood is permitted for all non-structural applications. 9% said wood is permitted for finished materials and trim only, and 78% said wood is permitted in the applications listed in Section 603.
That's definitely the safest answer, the best answer. If you have to check one, there might be some small truths in the other ones that don't want the other respondents to feel bad, but go to 603 for your complete list. That's the safest thing. Alrighty. I'm going to wrap this up with a number of wood features in buildings. At the very end, we're going to talk about reference standards as well. But I'll move through this fairly quickly. The primary value of this section of the Code Conforming Wood Design document, pages 19 to 25, is to give you a quick code reference to where to go. Where to go when you have a particular wood design feature and you need to know. You've got Class A. This is non-sprinklered buildings. So for these use groups and your exit enclosure and so forth, you're up to Class A. You have some exceptions in the footnotes. We won't take the time to go through them. You can check them in the Code Conforming Wood Design. But we'll see with sprinklered buildings, these all get shifted over here to B for your exits, and rooms and enclosed spaces for the most part are allowed to be C in all these use groups. These are flame spread classifications, the traditional ones, indicating allowable flame spread and using the designations A, B, and C to indicate a number for the flame spread rating that's in the code book. What is the flame spread rating of particular wood products and specifically species of wood? Here's another DCA document that you can use if needed to determine that. If the manufacturer doesn't have the information handy, if you have a specific species, it shows the range of flame spread ratings in this document, AWC DCA1. There are some exceptions for interior finish here in regard to the most common exception are for traditional wood floor covering, and 804.1 is not really regulated in terms of flame spread. Exposed portions of type 4 heavy timber structural members is not regulated. What about trim? Well, it has to meet a minimum Class C, and you're limited in the amount of trim that you can have in the building. 10% of the wall or ceiling area, that's 806.5. What about windows and doors? They can be wood, of course. Are there any particular restrictions? Well, it all depends on if there's a restriction on the wall itself. So go to your code provisions for exterior walls, and that's primarily in table 705.8. In general, if you have 30 feet or more from the lot line, you're home free, no restrictions at all. If you're 10 feet or more in types 2B or 5B, then no restrictions at all. You might say, well, wait, those are the unprotected construction types. Why is the fire separation distance less restrictive? In general, it's because of the smaller type of building associated with those construction types. and the types of hazards and use groups associated with those. No unprotected openings at all within 5 feet of a lot line in a non-sprinklered building, and none at all ever within 3 feet of a lot line in any building. So go to your exterior wall requirements for your windows and doors. There is a special code section on bay and oriel windows with an exception for fire retardant treated wood. In general, they have to be the same as the construction type of the building. What about interior doors? When do they have to be something special? You can have wood interior doors. Again, just like exterior walls, it all depends on the wall that they're in. Does the wall have to be rated for some reason? Check table 716.5, and you'll find out if that door itself has to have a fire resistance rating. Various requirements here for wood siding, which is regulated in 1406. See the height limits as a combustible exterior wall covering, minimum thicknesses, chapter 14 and 1405.2. As a siding material and a structural building material, you'd go to chapter 23. Wood used as an exterior wood veneer has a height limit. There's an exception for fire retardant treated wood. This is a similar height limit for combustible exterior wall coverings back in 1406. What about wood balconies and decks? Pretty much these are driven by one thing. As a general rule, whenever you can have a wood balcony or deck on a building of all construction types with conditions. The first one is you generally have to rate this floor somehow, floor of the deck, the same rating as the floor that it's adjacent to in the interior of the building. Whether you achieve that with heavy timber or some type of 1 hour protection if it's required to be a 1 hour floor. It can be wood, but it has to have the same rating. You're limited in that case to 50% of the perimeter of the building, and there's some other conditions in 1406.3. There are some exceptions for sprinkler protected balconies. By the way, in that same section it says that, of course, the guards and so forth, they do not have to be heavy timber. There's an exception there for those. Can you have a wood open stair on the exterior of a building? Yes, you can. When the building is type 4 or 5, there's a height limit, but the height limit is basically high rise. But if you have a type 4 or 5 building, you can have an exit stair, wood open risers on the exterior of your building. Here's the code sections to go to check all the restrictions. There's not many in this case. Wood roof covering, of course, is also regulated. There's test standards for the flame or fire resistance of wood shakes and shingles. Here's a little table that's in the code book summarizing the classifications for your roof coverings. You want to be careful here because in many cases you can have a classification for your roof covering, but one of the footnotes in the table itself says be careful if your jurisdiction uses the International Wildland Urban Interface Code. In other words, if you're in perhaps a fire district where you have fires, wildland fires, and you're maybe using Appendix D in the back of the International Building Code, then you're going to have some additional restrictions above and beyond these in accordance with the International Wildland Urban Interface Code. And it says so right in footnote 1 of this table. It alerts you to that. When you do have projections, here's the point with projections. Again, it's proximity to the property line. If you're less than 2 feet, shows in this diagram, you can't have any projections at all, period, in wood frame constructions or wood projections. Let's say you're up to 5 feet away from the property line and between 2 and 5 feet. Then if you can't have a projection up to the 2-foot point, but it has to be one of these things, fire retardant treated wood type 4 or rated for an hour. It's only when you get beyond the 5 feet, if you're over here, that this protection is not required for your projection. But if you're up to 5 feet, you got a 40-inch minimum there. You got to have this protection if you're within that 5 feet. But when you get, I take that back. I think I misspoke. This would be from 5-foot fire separation distance to the point over here where unprotected openings are allowed to be unlimited for your exterior wall requirements. Once you get past that, then none of this is required. Okay, so I misspoke at the very beginning there. Between 5 feet and the point where unprotected openings are unlimited, you still have to have this protection. 705.2. You can have many varieties of wood rooftop structures in Chapter 15 of the code. Penthouses, structure, mechanical enclosure or whatever, on top of a non-combustible building. You measure your fire separation distance to the property line even though you're on top of a tall building. Wood rooftop structures are permitted, of course, 1509. They're restricted as far as area and height. You do have some exceptions for using fire retardant treated wood in certain construction types. And as you're well aware, when wood is exposed to the weather, it needs to be pressure preservative treated. You go to 2304.11 for all the locations where you've got to have pressure treated lumber. This brings us to not quite the final section, but almost the final section, and that is precautions during construction. It's worth pointing these out for the sake of designers and code officials. There have been a number of wood structures burned during construction because they are at a particularly vulnerable point during construction. When the sheetrock is not in place, the notification systems are not in place, the construction is not finished. Of course, because wood is combustible, there's going to be a particular point where it's vulnerable during construction. The code anticipates this and has a number of provisions, and if they're ignored, will do no good. So we're going to point them out and highlight what's happened with these provisions in the code. They're all in Chapter 33 in the IBC and also Chapter 33 of the IFC, the Fire Code. First of all, you have fire extinguishers. Right now we're in the International Building Code. You have fire extinguishers required during construction at all stairways, all floor levels. You've got a lighted stairway required. This is for life safety purposes when you reach 50 feet during construction. You've got to have a functional standpipe for the fire service to use before the building construction reaches 40 feet. And then finally, in the International Building Code, your sprinkler system has to be tested before the building is occupied. If a sprinkler system is required, or even if there's anyone there, it has to be tested before the building is occupied. Now, something has happened in the recent edition, the 2012 IBC, that sends you directly to the IFC here. So you have a new provision in the International Building Code that sends you directly to the IFC for a whole list of requirements there of precautions during construction. This is a new requirement in the IBC in 2012. And so therefore, what that does is whether you use the IFC or not, these provisions are referenced and they're enforceable in the, and they should be followed in the IBC. What are some of those? Well, some are, we're very familiar with some of these. Precautions about temporary heating equipment, smoking is prohibited. A fire watch has to be maintained during construction if the fire code official requires it. Here's the main one. The owner, the project, through the designer perhaps, or through the construction company, the contractor has to have a fire prevention superintendent who has to be implementing a fire prevention program during construction. And then you've got other things, precautions about welding, accessible emergency phone. Firefighter vehicle access has to be provided during construction. An approved water supply has to be available. And there's other safeguards during roofing operations. All right, I'd like to just skip this poll question, if you don't mind, Michelle. I'm going to wrap up with a little discussion on the standards here, and then we'll go to a general question and answer session, if that's all right.
That sounds like a great plan.
Okay, thank you. Because we are running up against our time limit here. This is in the back of the Code Conforming Wood Design. Here are the referenced design standards in the IBC. You're very familiar with these if you design in wood at all, the NDS, special design provisions for wind and seismic, and the wood frame construction manual. How do we get to these in the IBC? Let me remind you that, first of all, if you were in the IBC, you go on the general provisions at the very front. It sends you right down here, and it says all wood buildings have to be designed with one of these alternatives: allowable stress design, load and resistance factor design, and so forth. That's where the NDS comes in, of course. That's the main design standard for all loads, gravity and lateral, for all the major elements in a wood building. You've got the provisions in the NDS for designing all the elements of a wood building, and that in turn sends you for your lateral load design, 2305, will send you to the special design provisions for wind and seismic. Let me talk, before I go to that slide though, I want to talk a little bit about this provision here, 2308 conventional light frame. This is also an alternative. However, it is very limited. What this section is basically residential framing requirements, very similar to what you would find in the International Residential Code. This is traditional conventional construction and framing techniques for many years of very practical experience. The scope of that section, 2308, one of the major limits is a 40 pound per square foot floor load. It has limited applicability in commercial construction. Back up here in 2301, another alternative is actually the wood frame construction manual. And we'll talk about those. Are traditional approaches to residential construction. But first of all, a note about the special design provisions for wind and seismic. I already mentioned in the NDS. And this one is the one that contains the requirements for your lateral load resisting systems for seismic and wind. 2305 of the building code references this directly. The latest edition is the 2008. 2305 of the building code still does contain some criteria for lateral force resisting systems, especially in regard to non-traditional connectors such as staples and so forth. That's still in 2305. But for most of the other lateral load resisting systems, shear walls and diaphragms, this is the one that you would use to design those. And the wood frame construction manual is permitted, first of all, you see right here in the cover it says for 1 and 2 family dwellings. This is a unique document that's come into use, was developed within the last decade or so as a prescriptive document for dwellings, but an engineered document. In other words, it contains the engineering criteria. The loads are calculated for all geographic loads now across the country, and it contains the tables and so forth necessary in a prescriptive way, similar to what we're used to for residential construction. It has the span tables and so forth, the connections. It has the appropriate tables to put together a building using the engineering, the loads and the engineering criteria of the model codes and ASCE 7, being prescriptive, it's a little more accessible, perhaps. The scope of buildings that can use the wood frame construction manual is limited, but that is broadening slightly with the 2015 IBC. There will be a little bit more use for the wood frame construction manual in commercial structures as long as they fit within the scope of the document for loads, building geometry, height, and so forth. So those are the main reference documents in terms of standards from the American Wood Council. Just give you a little taste of what's coming in 2015. There are some reformatted height and area provisions. By the way, they're looking a little bit more like what you're finding in the Code Conforming Wood Design tables. That's the same idea, some pre-calculation. So that's something to look forward to. You've heard of cross-laminated timber. We've done a lot of education on this in other formats. That will be addressed under Type 4 in the 2015 IBC. There is a handbook available if you wanted to know that. Here is the website, www.masstimber.com. Engineered rim boards have a new standard in the 2015. And then finally, as I said, there's a little broader application of the wood frame construction manual. There's a complete reorganization of the conventional wood frame construction provisions 2308. Those are the ones, again, with limited application. And then we have the new, the span tables reflect the new Southern Pine design values if you've been following that issue. I've finally come to the end of my slides, and we have 5 minutes to address a few more questions. I'll just remind participants, and I do appreciate your attention today, that if you have more questions specifically about something I've said, you're welcome to email me at pcoats, it's P as in Paul, C-O-A-T-S, at awc.org, or email our general info line that's on the screen here, info@awc.org, and here's our website address. So I think we have 5 minutes to take a couple more questions, Michelle.
That's right. And for those questions that we're not able to answer that are in the question box, we'll follow up with an email to everybody providing the answers to the questions that were in the box. Okay, the first question is the 1 hour fire rating on an exterior of the wall or on the inside of the wall? Oh, I'm sorry. Let me reword that. Is the 1 hour fire rating on an exterior wall from the inside of the wall or the outside of the wall?
That's a good question. And as a matter of fact, that's a change in the 2012 IBC, I believe, or the 2009 perhaps. When the exterior wall is within 10 feet of the property line, fire separation distance of 10 feet, so it's in close proximity to the property line, the code says you have to rate that wall for fire exposure from both sides. But if it's more than 10 feet from the property line, that wall is rated for fire exposure from the inside. That's what the code would require.
Great. That's a good question. Okay, one more question. If you have type 3B wall that requires a 2 hour fire resistance rating, do openings have to have the same rating when they are far from the fire separation line?
And the answer is no. The rating, the fire protection rating of those exterior openings would be governed by 705.8, table 705.8. And if you look at that table, in general, if you're 30 feet or so away from the line and 10 feet in many circumstances, then that opening is not required to have a fire protection rating. The point is, whenever you have a rating required by the construction type, table 601, type 3B, the questioner said, 1 hour rating or 2 hour rating. No, the exterior wall, the opening in the exterior wall that's rated, the wall's rated, the opening does not have to be protected unless you're within the fire separation distance to the property line. That 705.8 would kick you into a rating required.
Okay, great. Okay, and then let's see. This question, I think you know. I don't see wood floor coverings. Are they included somewhere or lumped into some other elements? I think they're talking about if you have a wood floor, what's a requirement?
Yeah. Traditional wood floor coverings, you'll find an exception in 804.1. 804 of the IBC has all the requirements for interior floor finish, and you've got an exception right at the very top for wood floor coverings. So they're largely unregulated, although, of course, if you just have wood down, if you have a particular manufactured product with some type of lamination or some type of covering, you'd want to check 804 to see what you might fall into in terms of flame spread.
Okay, here's one more question. Are structural insulating panels permitted to be used under the IBC?
Yes, of course. The code never restricts any kind of, unless it's outright prohibited, any kind of manufactured products such as structural insulated panels. I forget right off, I don't think they're addressed directly in the IBC. Someone may end up correcting me on that. I can't remember. If you go to Chapter 23, there are the general requirements for quality in Chapter 2302 and 2303. That would apply to structural insulated panels. But in general, I don't think there's any tables like there are in the IRC. The IRC has some very specific ones for 1- and 2-family dwellings and townhouses, tables and so forth for SIP construction. There's not those prescriptive provisions in the IBC, but you could, under alternate materials and methods, there's certainly ample documentation through research reports and so forth that SIP panels could be used and that kind of building could be constructed. Maybe someone can point me to the exact provisions if I'm missing them there. So.
You're talking about ER reports, the evaluation reports, when you said research?
Yeah, anytime, right. I'm sure there are many ER reports on structural insulated panels and that type of construction.
Great. Well, this is great. We had a lot of good questions, interaction with the audience, and hopefully the audience has gained some valuable information from this webinar. And for those questions that we have not been able to answer here in the webinar, we'll be following up with an email to the audience with the questions and answers. And so thank you, Paul, for presenting for us on this.
You're welcome.
Code Conforming.
Thank you, everyone. Thank you, everyone, for your attention.